Every AI comparison video you have seen this year shows the same thing. A table of benchmark scores, a quick verdict, and a thumbnail where one model has a crown on its head. Today we are doing something different. Claude 4.7 versus GPT-5, running the benchmark nobody is actually running. Before we get into the tests, we need to talk about why the standard benchmarks are misleading you. MMLU, HumanEval, Math, GSM 8K. These are the names you see on every leaderboard. They test specific, narrow skills under clean, controlled conditions. That is not how you use an AI model. Here is the ceiling problem. When two models both score above 90% on the same test, that test cannot tell you which model is better for your work. You are looking at noise, not signal. Yet those scores dominate almost every comparison video you will find. There is also a conflict of interest built into how benchmarks get published. The companies releasing these models choose which benchmarks to highlight. They do not publish the scores where their model underperforms. This is not a conspiracy, it is just marketing. But it means you need to run your own tests. So here is what we tested instead. 3 categories: multi-step reasoning across a long chain of logic, hallucination handling when the correct answer is unknown, and instruction following when the prompt contains competing or ambiguous constraints. Let us start with reasoning. For the reasoning test we gave both models a scenario with 12 interdependent variables and asked them to work toward a conclusion over 6 sequential follow-up questions. Each question built on the previous answer. We were not testing whether they got the final answer right. We were testing whether they kept their earlier reasoning consistent. GPT-5 produced confident, fast answers at every step. The problem was that by step 4 it had quietly contradicted a constraint it had accepted in step 2. When we pointed this out, it acknowledged the error immediately, but it had not caught it on its own. Claude 4.7 was slower, and it flagged the potential conflict proactively at step 3 before we asked. That difference matters if you are building an agent or an automated pipeline. A model that catches its own contradictions is not just more accurate. It is safer to deploy in a system where there is no human checking every step. Now let us talk about hallucination, specifically the kind that is hardest to catch. Both models are well trained to avoid fabricating facts about famous events or well-known people. The harder test is what happens when you ask about something recent, obscure, or simply unknown. Will the model admit it does not know, or will it construct a plausible-sounding answer anyway? We asked both models about a fictional but plausible-sounding research paper, a company acquisition that never happened, and a technical specification that does not exist. GPT-5 hedged on 2 of the 3 but provided a confident and entirely fabricated answer on the 3rd. Claude 4.7 correctly said it could not verify all 3 and asked for a source before proceeding. One fabricated answer out of 3 might sound minor. But in a research workflow or a legal document pipeline, one confident hallucination can cost hours of fact-checking or worse. The threshold for trust is not 90%. It needs to be much higher. The 3rd test is the one that surprised us most. We gave both models a complex instruction with 4 constraints, and we deliberately made 2 of those constraints slightly contradictory. Not obviously contradictory. The kind of ambiguity a real client or manager might introduce without realizing it. A weaker model will just pick one constraint and quietly ignore the other. A strong model will surface the conflict and ask for clarification, or at minimum explain which constraint it is prioritizing and why. This is the behavior you need when you are using AI to draft contracts, write policies, or configure systems. GPT-5 completed the task and produced clean output. It dropped one constraint without mentioning it. The output looked correct on the surface. Claude 4.7 stopped mid-response, noted the conflict, stated an assumption, and asked if that assumption was right before continuing. The output was longer and slower, but it was auditable. Auditable is a word that matters more and more as these models get embedded in real workflows. If an AI makes a decision in a pipeline and you need to understand why, you need a model that leaves a trail of its reasoning. Speed means nothing if you cannot trust or trace the output. So where does GPT-5 actually win? Speed and surface-level output quality on single-turn tasks. If you are writing a first draft, generating marketing copy, summarizing a document, or answering a clear factual question, GPT-5 is fast and the output is polished. For high-volume, low-stakes generation tasks it is a strong choice. Claude 4.7 wins on tasks where the cost of an error is high, the instructions are complex, or the work stretches across many turns. Long-form analysis, agentic workflows, legal or technical drafting, and any situation where you need the model to flag what it does not know rather than guess. The honest answer is that the better model depends entirely on the job. What the benchmarks will never tell you is that a 95% score on a clean test problem can exist alongside a 30% failure rate on the messy, ambiguous tasks your actual workflow contains. The takeaway is this. Stop making model decisions based on leaderboard positions alone. Run the tasks that look like your actual work. Test for consistency across multiple turns. Test for what the model does when it does not know something. That is where the real difference lives. If this kind of analysis is useful to you, hit the like button. It helps this channel reach people who want honest AI comparisons instead of sponsored rankings. Subscribe so you do not miss the next video, where we run the same framework on Claude 4.7 versus Gemini 2 Ultra on coding agent tasks specifically. That one has some surprising results.